Okay, this video is going to be going over the review for the Unit 1 functions test. So let me just zoom in on this first one here. This is just asking for you to put the linear function. This is f of x equals x. You can see I drew a straight line. We're at 0, 0, 1, 1, 2, 2, and so on. The x-intercept is 0, 0. The y-intercept would also be 0, 0. Now, I mentioned not to be too concerned about these right now, but for the others, for different questions, think of a max. This doesn't have a max. It goes on forever, so it's none. It also doesn't have a minimum, so it's none. Now, it's increasing. It's always increasing from negative infinity to positive infinity, so that's what we would call the increasing. And decreasing, well, there's none. We read left to right, it's always increasing, okay? And then when is it positive, when is it negative? Well, it's positive from 0 to infinity. That's how we write that out. We use our parentheses for both, 0 to infinity. And then negative, well, that's from down here, negative infinity to 0, okay? And that's what those are down at the bottom of these. And then each one of these functions asks the same thing, so you can just see we have x squared, that's our U shape. It does have a minimum of 0, 0, so that makes that one a little bit different. It does not have a max because it opens up. And then, of course, the x-intercept and the y-intercept are just 0, 0. It is increasing from 0 to infinity, and then it's decreasing going this direction, so from negative infinity to 0. All right, would be the, not sure I wrote that in there, but that would be the, that's the increasing and decreasing. Now, positive and negative, that's where I skip. Well, it's positive it's actually positive from negative infinity to 0, and then from 0 to infinity, okay? So yeah, just to repeat, if we're talking about the positive part of this function, well, everything above the x-axis is positive. We don't call the 0 positive or negative, so we could say this function is positive from negative infinity to 0 with a union of 0 to positive infinity. And of course, there is no negative, okay? Now, all of these are asking similar things, so I don't know that for the sake of time I need to go over absolutely every answer, but the x-intercept is where the graph crosses the x-axis, so this one does not have one because of the horizontal asymptote. It doesn't have a minimum or a minimum or a max, okay? And then, of course, the increasing, decreasing, you can see the answers here. So take a look at some of these answers. I will zoom in on them. Here's the absolute value. F of x equals the absolute value of x. Same thing, infinity, x and y-intercepts. There's no max because it goes on forever. The minimum 0, 0, and so on, okay? Increasing, decreasing, positive, and negative, all right? And then this is the square root function. F of x equals square root of x. See, it starts at 0 and goes out, positive forever. And then we can see the log function, log of x, looks like this. And then if we go to the next page, I will zoom in on the cubic. That's our f of x equals x squared. And you can see what this one looks like if I go over 1, or x cubed, sorry. If I go over 1 and cube it, that's 1. Over 2, that's 2 times 2, which is 4 times 2 is 8, so 2, 8. And then -1, -1, -2, -8, and so on, so it creates that function. And you can see our minimum, maximum, or none, and so on, okay? Cube root of x looks more like this. The cube root of 1 is 1, the cube root of 8 is 2, and then -1, and so on, and -8 is -2, okay? And then you can take a look at all of these down here, all right? And then this last one we're looking at is rational. This one's pretty unique. This one, I'll go over this one a little bit. There is no x or y-intercept. Those are the asymptotes. You have a horizontal asymptote as the x-axis, and the y-axis is the vertical asymptote. There's no max, there's no minimum. And let's see, the increasing, there's actually no increasing. From left to right, it's actually decreasing, okay? It's actually decreasing from left to right. So decreasing is from negative infinity all the way up to 0, where 0 is not included, so we use the parentheses. And then we have the union with 0 to positive infinity. So we pick back up at 0 to positive infinity. Again, 0 is not included, so we use our parentheses. and not our bracket, all right? And then positive is, the positive is from 0 to infinity, and the negative is from negative infinity to 0, negative infinity to 0. All right, so that's just a look at those characteristics. Now let's go to the next page. Or actually, let's just look down here at the bottom. So here you have a graph. It wants you to write the domain and the range in interval and inequality notation. So the domain is the x-axis. So we're moving from left to right, from least to greatest. So you can see this point here, which is a shaded in circle, is at -8. And the graph goes all the way over to +4. So here's your interval notation, -8 to 4. That's least to greatest. We use brackets because it's a solid or shaded in circle. Same thing here, that's a shaded in circle. So those x point values are included. Okay, and inequality notation just looks like this. Again, x is the domain, and this says the domain is greater than or equal to -8, and it's less than or equal to 4. We read it from left to right, but -8 less than or equal to x, less than or equal to 4. Here's your range. Again, that's from bottom to the top. So we're going from -8, which you could either use this point that's shaded in or this graph, the low point touches -8, so it's included. That's why we have the bracket from -8 all the way up to +8. So again, we use our bracket. This is what it looks like in inequality notation. We put the y in the middle. We use our less than or equal to symbols because they're both shaded in or touching that, that line. So -8 less than or equal to y, less than or equal to 8, okay? This one you'll notice it's very similar concept except for we have an open circle. So when you go from least to greatest on the x-axis or on the domain, you're going from -11 with a parentheses all the way up to +11 or all the way over to +11 with a bracket because it's included. This is how you write that in inequality notation. Notice this is the less than and this one is the less than or equal to. That's the difference in an open circle and the shaded in circle. The range from bottom to the top. So from -11, open circle, so we use a parentheses, all the way up to 4 with that bracket right there, 4. And this is what it looks like in interval notation. All right, next page. So this section is asking for you to determine whether this graph represents a function, or determine whether the relation below determines a function, and then justify your answer. Well, you see this one, this function, it's actually at y equals -5. It is a function, and you could say it is because you use the vertical line test and notice that it doesn't intersect at more than one spot. That just means there's not multiple outputs for one input. Over here on this graph, this is not a function. Same thing, you could use vertical line test and notice that it intersects there and there. So the vertical line test would prove that it's not a function, or you could say that there are repeating x values for the same input. This 4 has an output here and an output here. That's not a function, okay? All right, and then same thing here, you're just given some discrete data, but there's not a repeating x value with the different outputs. So is it a function? Yes, and like I said, no repeating x value. This is just a different way of showing the input and the output, or the x and y, or the domain and range, the mapping. So there's not, or this is a function because there's not an x value that has more than one output. So it is a function as well. All right, and then let's take a look at the bottom of this page, and then we'll end this part 1 of this video. So there's a lot going on here on this page, but what it's asking is for you to find or to evaluate f of 6. All right, where you're using these functions at the top. This is what we worked on in class on the last day before the test. So if you want to find f of 6, well, here's the function f of x, and it's -2x minus 5. That means the x value will be replaced with whatever your value you're being asked to find, and it's -2 times that value. So we take the 6 and we replace the x with 6. We always put that in parentheses. So -2 times 6 and then minus 5. And -2 times 6 is -12. -12 minus 5 is -17. So f of 6 equals 17. Now let's move on over to this one. This is g of 3 with the capital G. You can see that function here. It says 2 times the x value squared plus 3 times the x value minus 4. So if you're asked to find g of 3, you're going to replace the x value with 3. So it's 2, and then in parentheses 3 squared, plus 3, and then in parentheses times 3, and then minus 4. Square the 3 first, that's 9. 2 times 9 is 18, and then 3 times 3 is plus 9 minus 4. So all of this, 2 times 9 plus 9 minus 4 is 18 plus 9 minus 4, which is 23. All right. You can see I have all these other examples here. I'm just plugging in the value and working it out into the function. However, it looks a little bit different here. G of x plus 2. Well, g of x wants you to multiply 3 times the x value minus 3. So we're going to replace the x value with x plus 2. So I'm going to use this 3, and then in parentheses, I'm going to put x plus 2. So 3 times x plus 2 minus 3, okay? What I've done there is I have taken this x plus 2 and replaced this x value there and worked it out. And I got 3x plus 3, all right? This one is a little bit more challenging because in the function g of x, we have an x squared. So 2x squared plus 3x minus 4, everywhere we're seeing x, now we're going to replace it with x plus 1. So we're going to be taking this and replacing it on the x, where the x is, okay? So you can see it worked out here. 2 times x plus 1 squared plus 3 times x plus 1 minus 4. This x plus 1, you have to FOIL it. That's a binomial. X plus 1 times itself. X plus 1 times x plus 1. When we do that, we get x squared plus 2x plus 1. And all that get multiplied times 2. Okay? Let me blow that one up just a little bit. So, so we get x squared plus 2x plus 1, and all that gets multiplied times 2. And then, of course, we finish this out. Plus 3 times x plus 1, that's 3. 3 times x is 3x. 3 times 1 is plus 3. And then bring down your minus 4. And then distribute this 2 to all 3 of these terms inside this parentheses. And you get 2x squared plus 4x plus 2. And then the rest of it plus 3x plus 3 minus 4. Combine all of that, and your new expression is 2x squared plus 7x plus 1. That's your new polynomial. All right. So now, I know in interest of time, I'm trying not to cover everything in major detail, but here's f of 6 plus capital F of negative 1. Well, we already worked out f of 6, and we got negative 17. I'm just pulling that from up here. F of 6 is negative 17. And then I find f of negative 1. So I just plug in negative 1 squared minus 2 times 1. I did all that in parentheses. You can see that here, negative 17 plus negative 1 squared minus 2 times negative 1. And when we work all that out, inside the parentheses, negative 1 squared is 1. Minus 2 times negative 1 is plus 2. So that's negative 17 plus 3, which is negative 14. All right, now let's look at these. These are a little bit more different, so pay attention to these for sure. This says g of x equals 21. So it's not asking you to plug in 21. It's saying g of x, which is a function you're given, is equal to 21. So what I've done, and sorry, I'm going to have to zoom out here. This g of x is 3x minus 3. So I'm replacing gx with 3x minus 3, setting it equal to 21, and then I'm solving that equation. 3x equals 24 because I added 3 to both sides, and I divided by 3, and I got 8. So when the y is 21, that's because x was 8. We plugged in an 8, all right? And then last over here, same thing, h of x equals 15. Well, you'll see up here that h of x is x plus 5. So what this is saying is x plus 5 has to equal 15. I solved this equation and x equals 10. So x would be 10 when y is 15. All right, that's the end of part 1.